Hello students, I am Suraj Prasad. I am a BTech graduate from IIT Patna with electrical engineering, and I have been associated with askIITians for the past 4 years as a chemistry tutor, IIT. Today I will be teaching you the chapter of chemical bonding and molecular structure, so it's better to grasp your knowledge on these topics, which covers all the theories related to the molecular structures, the formation of bonding, ionic and covalent bonding, and which will start with the topic of Lewis dot structures. So let's start the chapter chemical bonding with the topic of Lewis dot structures. Our first topic is Coastal-Lewis approach. Let's see. Coastal and Lewis, they were the first who gave something that how there is formation of chemical bond, which is just the attraction of different molecule species among them, right? It is that attractive force which is holding them together. And they gave something with respect to electrons present. And they said that they form molecules or the atoms get bonded because they want to become more stable as your inert gas is compared. Because in case of inert gas, if you see, they have their octet complete. So they gave something regarding which was considering the octet complete theory. Let's see. What was their approach? They said that you can assume atom, okay, you can assume atom in terms of a positive charged particle or positively charged sphere called as kernel, and the rest electrons of outer shell, or I will write here valence electrons, right? That which can be accommodated is 8, number is 8, so that the octet becomes complete, and they are like inert gas. Like inert gas, I mean to say neon, argon, okay, which have their last cell complete. So Lewis call it kernel, right? And it was based upon stable octet theory, because we all know that noble gases are the most stable. They have their octet complete. And how did he represent the symbol? He just wrote the symbol of atom with valence shell electrons it is having. For example, if I am writing here in N2, then say here there is N here, right? And the valence number of electrons will be equal to 5. So here there are 2 electrons, here there are 3 electrons. Similarly for this nitrogen also, here there are 2 electrons, here there are 3 electrons. And he said that in order to complete their octet, there will be some adjustment. There will be some adjustment regarding octet completion. And it is in this way that a bond gets formed. You can say in case of N2 how it gets formed. In case of N2 molecule, it gets formed when each nitrogen, you can see each nitrogen is sharing its 3 pair of electrons. And that's why we say that there is triple bond in N2. So this was his approach, that in order to complete the octet, every molecule or every species, every atom, what it does, it shares or adjusts its electrons in such a way, to complete its octet. You can see here in C2H2 also. And these are the Lewis dot structures for the elements known at that time. Hydrogen, lithium, these are first group elements. This is down the group. You know that alkali metals, they all have know, valence number of electron 1. You can see the atom is represented by element sign representation, and with a valence number of electron here. In case of group 2 it will be 2, then 3 it will be 3, 4 here it is 4 like carbon, right? Then it is a pentavalent nitrogen, here it's 6, 7, and here you can see helium is the case of doublet, rest are octet. So Lewis observed his theory with regarding octet completion of elements, and this he said that this is the reason why atoms combine to form a bond. And what is the significance? The significance was that the valence number of electrons, they help to calculate the common or group valence of that element. In the whole group, if you will see, the number of valence electrons will be the same. Okay, so it will be easier to analyze the whole group elements properties with regarding to bonding is concerned. And the valence number of electrons, the group valence will be equal to either equal number of dots, which I say valence electrons, okay, or 8 minus valence electrons. This will give me what? This will give me the group valence, that I will say as oxidation number. Oxidation number, which is the combining capacity of the atom. And how do I adjust number of electrons in a molecule? For example, if I have to draw a Lewis dot structure of any molecule, how I will draw it? There are some rules. We have to first calculate the total number of electrons. Total number of electrons. We have to calculate the valence number of electrons, plus if there is, anions, then obviously you will add one electron. You have to add one electron or the charge of that anion. For cations, you will subtract one electron from the total number of valence electrons. Okay. Then, of course, you must know the chemical symbols of all the atoms there in the molecular formula, and then it has been observed that, I will put a star here, it has been observed that in general the least electronegative atom, it occupies the central position. Okay, and then you have to arrange the electrons so as to complete each and everyone's octet ready. Okay, this is how there will be bond formation. Now let's study with this video. You can see here in CO2, carbon is having 4 valence electrons, and oxygen, if I write, then I'll be having 2 atoms of oxygen which is having 6 valence electrons per. So that counts to total 16 electrons. Now if I'm gonna write or arrange the 16 electrons, I will arrange it in this order. I will say right here C, then OO, and then I'm arranging all the 16 electrons like this. They are total 16 here. But is it possible, guys? You see, for oxygen the octet is getting complete. For this oxygen the octet is getting complete. But what about carbon? In carbon, octet is not getting complete. It is having 4 electrons still. So that means this is wrong. There is something wrong, and I put electrons here to share. Now you see oxygen is having octet complete, but here carbon again is not having that octet complete. So what I will do, I will take 2 electrons from here also and will put up a shared pair here. Now you see both the oxygen atoms and the one carbon atom, they have their octet complete. So this will be my Lewis dot structure. This will be my Lewis dot structures, because here I can see that my octet for both carbon as well as oxygen is getting completed. So there will be a double bond between each carbon and oxygen atom here. These are some of the Lewis dot structures of very famous molecules like HF, N2, NH3, CH4, CF4, NO+. What I am doing, I am just calculating a total number of valence electrons, okay, and I'm trying to form bonds by single bond, double bond, like that. And if these structures are possible, then okay, otherwise I am rearranging the bonds here and there. So that's what you have to do for Lewis dot structures. Thank you. So students, we did learn about the Lewis dot structures, which was the basic concept given by the causal Lewis to understand the chemical bonding which is happening in the molecules, right? And also we did it by taking a video also. We did learn it from a video also, and we did study how to write the chemical symbols in the form of Lewis dot structures.